So for this analysis, we're going to be talking about regression, and we'll be doing a simple linear regression. In our data set that we are looking at height and shoe size. And remember, we're looking to see if something can predict the other. We have an independent variable and a dependent variable. So our research question here will be, is someone's height a significant predictor of their shoe size? So what we have is we have 30 people. You'll see 30 people there who we had their height in inches and their shoe size in just standard US shoe size. On the variable side of this, what you'll see is the height and the shoe size, both of them being numeric. We don't have to do any values or anything. They're both scale variables. We can average these, and then our height in inches and someone's shoe size as far as the label. There it goes, just so we can keep it straight. So on the front side, height and shoe size. To perform a regression analysis, all we do is we go up to Analyze, and we go to Regression, and for this type of regression analysis, we just go to Linear. Now here's what our dialog box is going to look like. So we have height in inches and someone's shoe size. That's what we put the label as for each one. Now we have to first put the dependent variable, which is what we're predicting, into the dependent variable field. Now we are predicting someone's shoe size. Does height predict someone's shoe size? So we go over and predict. We say we're going to predict their shoe size, and then the independent variable, we're going to do it based upon the person's height. That's what is predicting someone's shoe size. So put that in independent variable. Now for a simple linear regression like we're doing, we don't have to mess with any of the other options. We just go ahead and say run. And this is what the output will look like. Now our output is going to tell you what variables we've used. Basically the independent variable up here, the dependent variable down here, it tells you what that is. Then it goes into our model summary, our ANOVA, and then our coefficients. And we'll work through each of those boxes when we do our write-up. Now the first thing we're going to look at is the ANOVA table, just to see if our overall analysis is significant or not. All right, we look right here at the significance value. Since it's an F-test, it doesn't have to be two-tailed, it's just a one-tailed test, and that's fine. And we see that our significance, 0.028, is less than 0.05. That's our alpha. And since it's less than 0.05, we reject our null hypothesis, and it is a significant result. Remember, reject and significant. So we reject it, it is significant, so we can write up the results from that. So let's just go ahead and write that up. We'll put in a little text box, new text down here, and let's just go ahead and write up the test result first. To report a F-test, which is what this is, since we're doing an ANOVA F-test, then we do F, and then in parentheses we put our degrees of freedom, our 1,28. It comes from right there. We say what the F statistic equals with 2 decimal places, 5.39, and then we do the p-value. You can do the exact p-value if you'd like, or you can just put that it is less than 0.05. Okay, so now that we've got that, what else do we need to put in there? Well, since it is significant, we're going to want to know what proportion of the variance is explained by our regression model. Okay, and to do that, we look up here at the R square, not the R, the adjusted R, but the actual R square. Okay, so in doing that, we are seeing how much when someone's shoe size naturally varies, we're seeing how much of that is because of their height. And so it tells you how much of that natural variation is explained by another variable, in this case, height. So, since it is significant, we can write in the R square. So you have R, and then what we can't do in SPSS is put a superscript for square, but we can go ahead and just type that 2 in. When you do it in Word, make sure you make that a superscript. That way it's a proper looking square. Now we put our r squared in 2 decimal places, 0.16, so we can say 0.16 and put a comma there as well. Now, we need the literary description as well. So what did we actually find? We didn't necessarily find anything like, one is significant and the other one's not or anything like that. But what we're trying to say is that one of them significantly explains a proportion of the variance in the other. Now you can follow your guide or you can follow this guide, either way, and just say that your independent variable explained a significant proportion of the variance in the dependent variable. So in our case, it's height explained a significant proportion of the variance in shoe size. And then since you have your statistics in the line, you just put a comma there and let the rest of your statistics follow. And that's it for the APA style write-up for it. Now, if it was not significant, you would just put height did not explain a significant proportion of the variance in shoe size. You would leave out the r squared, but you would still report your F statistic as it was up here. So however it comes out, if it's not significant, then you report it that way here. Now, the other thing I want to point out is how to use your data, your output to write an equation. Now remember what we had. We had the y equals mx plus b for our linear equation. Well, that all we're doing there is we're adding in our what there are as far as being relevant to our analysis. So our y is our dependent variable. Our x is our independent variable. The m is the slope or the coefficient that goes along with our independent variable, and the b is the y-intercept or the coefficient that goes along actually with our dependent variable. And I'll show you where they find these. Now, first, what we'll do is we'll add in, instead of y and x, we'll add in our dependent and independent variables. So for our dependent variable, what we predicted, right, is the shoe size. So shoe size, and then our x is our independent variable, so what we're using to predict, so height. Now, for our coefficient that goes along with height, we go up to the coefficient box, or our slope, as we're also calling it. So it's the coefficient that goes along with height, and we look in this first box right here, the B. The unstandardized beta is what it's called. Now, you go height, straight over, right here, 0.17. So instead of our slope there, we have 0.17. And then, for our B, or our y-intercept, we go up here to the constant and the unstandardized beta, negative 1.48, and that's what we associate with negative 1.48. We associate that with our y-intercept. Now, what I said was that was associated with our shoe size, and that's right, is what it is. It's basically that you are starting at a point, so you're starting at negative 1.48, and then for every inch tall that someone is, you add 0.17, and then when you're done, then you end up with their predicted shoe size. Now, since we've got a plus and a minus here, then we'll just go ahead and change this sign to a minus. So that's how you write your linear equation. That's how you write your APA output for a linear regression.